Will you look at that? Only 3 questions this time. This must make it easier. Not. Okay, this time is cylinders and cones. So I hope you know what a cylinder looks like, and I hope you know what a cone looks like, because this is what makes this difficult, if it's difficult. So cylinders look like this. Okay, that's a terrible cylinder. They are straight up and down. And cones, depending on their orientation, meaning whether they are upside right or upside down on your viewpoint, they do not go straight up and down. They go on angles. So this makes a huge difference. So you have to be very, very careful, because you are supposed to like cylinder questions better and cone questions worse. Not that unhappy. There's no tears. All right, so we're going to start with a cone. That way, when we get to cylinders, you'll be super happy. So the first question is, water is running out of a conical funnel at the rate of 2 centimeters cubed per second. So I have just given you a volume rate. And because it's running out, I need the negative sign. How do I know it's volume? Centimeters cubed. If the radius of the base of the funnel is 4 centimeters and the altitude, which is height, is 8, this is the original cone. Find the rate at which the water level is dropping, so we're expecting a negative value, when it is 2 centimeters from the top. So that means we're looking for height when the height is 2 centimeters from the top. So I'm going to need a picture for this. Hopefully better than one of the ones up here. So because it's a funnel, I am going to orient it the way I did there. So not like a traffic cone, instead this kind of cone. And I've given you the information that the height originally is 8 centimeters. And the radius is 4 centimeters. And if drawn properly, it is at 90 degrees. Then I need a volume formula. So a volume formula for a cone is 1/3 pi r squared h. I teach grade 9. I know this. And do you see a problem with this? It is that if I take the derivative of this side, it's 1 dv by dt, and then I get to this side and I've got 2 letters. So I'm not even going to start this yet, because I need to keep my h's and get rid of my r's, and that's what this picture is for. I have not dealt with the fact that the water is 2 centimeters from the top yet. I'll deal with that in a minute. So what you have to do is you have to realize that if the water is here, and if the water is here, and if the water is here, both the r is changing and the h is changing. So the r doesn't stay the same. This is 4, this is less than 4, this is less than that, this is less than that, and as the water level decreases, the radius keeps getting less and less and less, as well as the height getting less and less and less. So what you build is something called an RH ratio. So r's compared to h's. And you compare the original size. So 4 compared to 8. And then I'm going to cross multiply, because it's a perfect opportunity to cross multiply. So 8r equals 4h, or 4h equals 8r, your choice. And what we have to do is we have to keep the h's, because that's our question. So that means I have to get the r by itself. 4 divided by 8 is a half, so I'm going to write it like that. Okay, so now I have to put this in here so that the right-hand side is all h's. So v equals, so you see why I couldn't take the derivative yet. I'm not at that point, so h over 2 goes in for the r, don't forget to square it, and then the other h So this is why cone questions are not supposed to be your favorite. So square h, square 2, and we still haven't taken the derivative, remember that. V equals, so I've got 1 over 12, 3 times 4 in the denominator, pi, and then 2 h's and 1 more makes 3 of them. And now it's perfectly set up to do the derivative. I'm going to do it here just because I have space. So left-hand side, 1 dv by dt. Right-hand side, 3 over 12 pi h, 1 less, so squared, dh by dt, which is what we're looking for. So dv by dt equals 1 over 4 pi h squared dh by dt. Now I'm going to put in my values. So dv by dt is negative 2. My 1/4 stays 1/4. My pi stays pi. My h is unknown. My dh by dt is what I'm looking for. So let's go back to find out what we have to do for h. Purple water. We want to find out the rate at which the water level is dropping, so that's the height is dropping, when the water is 2 centimeters from the top. So there's my purple water. This is 2 centimeters. But if you think about it, this little shape right here is not a cone. This bottom part is a cone, and because that's 2 and this used to be 8, I'm going to use an h of 6. Don't let me forget to square it. So negative 2 equals 6 squared is 36, times 1 is 36, divided by 4 is 9, pi dh by dt. The object of the game is to get the dh by dt by itself, so divided by 9 pi, divided by 9 pi. This is where the slashy fraction people are going to have extra hand movements. I do not, because my pi is obviously in the denominator. And even though I've got a negative answer, I want to do only one therefore statement this time. So the water level is dropping. Level is dropping. That is a directional word. At, and because it's a directional word saying it's getting less and less and less, I take the negative out of the answer. It's centimeters, because I can see that here, per, go looking for my time, seconds. It could be minutes, it could be hours. And we have that. The option is, I'm not writing it down, the water level is changing at negative 2 over 9 pi centimeters per second. All right, let's see what's next. Cylinder. Oh, okay. That surprises even me. I'm going to draw my crazy cylinder right now. Okay, this is better than the first one. Do you see why the cylinder questions are a little bit better? It's because if the water level is here versus here versus here, the water level is changing, but the radius isn't because it's a straight up and down shape, three-dimensional shape. So let's read the question. A cylindrical tank has a radius of 3 meters and a depth of 10 meters, so that's height. It is being filled, so no negatives, at a rate of, there's a meters cubed, and there's the minute again that I mentioned might happen, 3 meters cubed per minute. How fast is the surface level rising? So this time, the height of the water, the surface level, should be positive, and it will be because we've got no negatives. All right, so formula time. the volume of a cylinder is an awful lot like the volume of a cone. Volume of a cone and the volume of a cylinder are the same, only because this is pointy, it is times 1/3 or divided by 3, depending on how you look at it. So that's something you teach in grade 9, applied math. I don't know if it's in academic because it's been a while. All right, so my dimensions here. So I'm going to put 10 meters there, and I'm going to draw me a little radius and put 3 meters here. And what I need you to know is that you can't take the derivative of this either, because on the right-hand side you've got 2 letters. But the thing that makes these questions easier is that if you think about it, the radius is going to be 3 regardless of the water level. So I get to put in 3 right there before I take the derivative. So that means I've got 9 pi h on the right-hand side, and that's super easy to take the derivative of. So dv by dt, or 1 dv by dt, equals, there's a little 1 up here, 9 pi h to the 0, which isn't there, and then dh by dt. So dv by dt is 5, written right there. That doesn't look like minutes. Hey, I don't even get to put in an h, because it doesn't matter in this question. But what does matter is where you put your pi if you're a slashy fraction person. I am a stacker. I have no problems. And then I get to write my therefore statement. So how fast is the surface level rising? Therefore, the level is rising at 5/9 pi. We just found height and time. So that's meters, not meters cubed or meters squared. And time was minutes. There, that minutes looks better. All right, last question for this stuff. Also from the booklet. So, this looks wordy. All right, so the radius of a right circular cylinder, meaning a straight up and down cylinder, oh big yawn, increases at the rate of 3 centimeters per minute. dr by dt is equal to 3 centimeters per minute. I'll get to the picture in a second. At a specific instance, the radius, so this is not the beginning, the radius and the height of the cylinder are 6 centimeters and 15 centimeters respectively. What should the rate of change of height be so that the volume remains constant? Okay, so this means that dv by dt is 0. And just to impress you, 0 centimeters cubed per minute. And it's 0 because if the volume remains constant, the change in volume is nothing. So, I'm going to try this without a picture. V equals pi r squared h. So here's a bit of a problem, and I lied to you. The problem is that we need to keep our our r's because we need dr by dt to input, and we need to keep our h's because we need dh by dt to answer the question, and we need our v's. So I've always told you up to this point in the 2.5 notes we've done, 1 2/3 notes we've done, is you have to have one letter on the right-hand side. And that's actually a bit of a lie, because what you can do is you can slice it and do the product rule, which doesn't seem like a great trade-off, but that's what you have to do in this question, because you've got more information than 2 letters worth. You've got 3 letters worth of information. So on the left-hand side, 1 dv by dt. On the right-hand side, the derivative of the front part of this, so 2 pi r, but it's an r, so dr by dt, times by the back. Product rule. Plus the derivative of the back, but it's an h, times by the front. And now I should be able to input all this stuff. So I can put in 0 for dv by dt. I can put in 6 for r. I can put in 15 for this h. I can put in 3 for the dr by dt. Doesn't matter what order I do it in, it's all multiplying. Plus, dh by dt is staying unknown. 1 is staying 1, pi is staying pi, r is 6. Don't forget to square it. So 0 equals 30, 90, 540 pi plus 36 pi dh by dt, negative 36 pi dh by dt to try to get the unknown on one side and the knowns on the other. Divide by negative 36 pi. Divide by negative 36 pi. Yay, my pi's will cancel out. And I will be left with dh by dt is equal to 540 divided by 36, I'm not going to put the negative in, is 15. So I've got negative 15 as my answer. So to reread the question, what should be the rate of change of height? Therefore, the height is changing. There's that vanilla word, no direction, at negative 15 centimeters per minute. Centimeters because it's still height, minutes because it's still minutes. All right, so does that make sense to you? Does it make sense that you have a negative answer? And to me, it does make sense, because if you are trying to keep your volume constant, so if you're trying to keep your volume not changing whatsoever, then if your radius is getting bigger, your height has to be getting smaller, and it does. So this does have some logic to it for me. All right, there's the stuff. This is a challenge question, I believe. Otherwise, that's usually what I do with the square brackets. So that is that for cylinders and cones, and we'll be back to do another kind shortly. I hope to finish related rates today. Yeah, great holiday.